Hello, welcome to this video. This is lesson 2.4 or 2-4 for Accelerated Math 3, and we're talking about rational expressions, and our objective of this lesson is to create a rational function from two different rational expressions. This video will incorporate a lot of review, especially from lessons 2.2 and 2.3, which is adding and subtracting rational expressions as well as multiplying and dividing rational expressions. If you got those two lessons, this lesson should be fairly simple for you. The only new thing is just adding in the notation. Okay, so without further ado, let's go ahead and look at this idea. This says one way to create functions is to combine two or more functions using a basic operation. And again, like I said here, the only new thing that really is new is this notation here. So this says f plus g of x, right? And all this is you're adding f of x and g of x. Simple enough. How about this one? F minus g of x. And that's how you read that, f minus g of x, right? Just like a regular function. Okay, and you subtract the functions. All right, how about f times g of x? Well, what do you think you do with f of x and g of x? You time it, okay? And then here, f divided by g of x. Well, we're going to divide them. Simple enough. I'm going to split this into two separate videos, so I'm just going to start with the first two, which is addition and subtraction, okay? So here's our first example. Please write this in your notes. And it says, given the functions f of x and g of x, create the following function. And they want f minus g of x. Okay, so you're trying to trick me with this notation. It's not going to work, right? Okay, it might work for Joe. Joe who? Okay, so we have f of x minus g of x. Okay, so that's all they want you to do, create your new function. Okay, so I'm going to go ahead, I'm going to substitute. So here's f of x. Okay, I'm just going to plug this in. So this is x plus 2 over x. And minus g of x. Okay, well, g of x is given here. So I just substitute it in. 4x minus 1 over x minus 1. Okay, now we just have a regular subtracting rational expressions. You're going to have to find your LCD, which clearly our LCD here is x and x minus 1. So we'll just introduce those factors. So x minus 1 multiplied by x minus 1. Over here, I'm going to multiply by x, multiply by x, okay? That's kind of the shortcut way. And what I get, x squared, negative 1, or sorry, x times positive 2 is positive 2x, negative 1 times x is a negative x, so all we have left over is a positive x. Okay, over our LCD, minus, I'll put this in parentheses, x times 4x minus 1. Okay, all over x times x minus 1. I could have distributed that. So we have x squared plus x minus 2. Here we have minus 4x squared minus x. Over x times x minus 1. Okay, and we're just going to change the signs on this. On our second terms, right, this is going to become negative. This will become positive. So we have negative 3x squared when combined with our x squareds. Over here, we get plus 2x and minus 2. All over our term, x times x minus 1. Okay, and that's it. Here's our new function. Okay, there. Now, actually, I'm gonna adjust this. So they want a new function. Generally, when they want something in a function, write it in function form. So I have this is f minus g of x is equal to negative 3x squared plus 2x minus 2. All over x times x minus 1. So here's a function. Okay, there, that would be your answer that you would box. Make sure you rewrite that notation. Okay. Here is example 2. Okay, and they want f plus g of x. Well, okay, what do you think they're going to want us to do in this example? Add them. That's right. Okay, so I have my two functions. We'll substitute x plus 4 plus x squared minus 4 plus x minus 2 over x plus 2. We can simplify, or not simplify, we'll factor this. X minus 2, x plus 2. If you see that right away and you want to do that, feel free to jump right away into the factoring. It will save you a line. Okay, here we go. And I need to find a common denominator, right, in order to add these. So my LCD, right, is going to be x minus 2, x plus 2. And I'm just missing on this factor x minus 2. Okay, so computer's acting up. Okay, so what we get is x plus 4 plus, and then over here this is going to give us x squared minus 4x plus 4 all over our denominator. Okay, and then here is our final answer. So we have x squared minus 3x plus 8 over x minus 2, x plus 2. Okay, and then again, this is f plus g of x. There's your function. Okay. Maybe you're wondering, where the heck are the excluded values? Why don't they ask about excluded values? There are still excluded values here. It's just the problem's not asking for them. Okay, I don't have to state my excluded values. If it wants it, we'll give it. It's not asking about any of the discontinuities, right? So there it is. We have done our objective, creating rational functions using operations. That was addition and subtraction. I'm going to post the practice problem right here. Okay, so this is for you in your notes if you have room. If not, do it on a whiteboard. Please pause the video right now, and then I'm going to click to the next slide so you can see the answer. Okay, pause it. All right, hopefully you pause the video, and here are the solutions. Okay. And you have two different ways. Just note too, in the denominator here, this is in factored form here. They put it in standard form. Either way is okay. Again, like I said, I kind of like this method here because you can see the discontinuities or the asymptotes fairly easily, right? That'll be important for next year in calculus. Okay, that's the end of this video. I'm going to do another video, second video, that will focus specifically on the multiplication and division. All right, catch you next time. Welcome back. This is video 2-4. We're talking about creating functions for rational expressions. Again, this is just a review from 2-2 and 2-3. The only real new thing is the function notation, which is important. And this video, part B, is specifically going to focus on multiplication and division. Okay, so without further ado, make myself smaller. Okay, there we go. Here is the first example. We are asked to create the rational function with given operations, and given the function f of x and g of x, create the following function. So they want f times g of x. So plain and simple, what they want us to do is to multiply f of x with g of x. Okay, so I can go ahead, I can copy down f of x, which a shortcut that I'm going to do is I'm just going to go ahead and right away factor it. Right, so this is the same exact thing as this. Same exact thing. Okay, now I'm going to multiply with g of x. Well, they're getting tricky here. Okay, 2, and this is x plus 2. Okay, and again, this is the same as that. Okay, so what I want to do now is I want to go ahead and reduce. I'm going to look for common factors, top and bottom. I have x plus 2, and that's it. They're trying to catch you slip in here with the x squared plus 3. They want you to think you can factor that, or that's the same thing as one of these factors. That's not the case. Okay, so what we have here is x minus 6 times x squared plus 3 over 2 times x minus 3 times x plus 3. Okay? Need a thicker pen color. Okay, and what I'm going to do, I'm just going to multiply this out. So we have x cubed along with a positive 3x minus 6x squared minus 18 all over our denominator. Okay, and then I'll write it in standard form. I just gotta shuffle two terms, 6x squared plus 3x minus 18 all over 2 times x minus 3, x plus 3. Okay, and again, the notation, f times g of x. All right, there you have it. Sorry, that was a little fast. Oh, and I forgot a parenthesis. How dare I? Okay, here you go. And here's the last example. Here they want you to create f divided by g of x. So once again, what they're asking, they want f of x divided by g of x. Okay, so I can substitute both of those in here, right? So I'm going to substitute in f of x. Here's f of x. Okay. X plus 7, x plus 1. Over x plus 3, x minus 2, it looks like. Okay. Now, I could write division, and I can copy this down, but in order to save some time, right, you guys know what to do. When we divide, what do? That's right, we multiply by the reciprocal. Okay, so we have x plus 2, x minus 2, over x plus 2, x plus 1. Okay, and I'm going to highlight just to help you kind of track that, right? The divisor is now, or the denominator is now the numerator, and our numerator is now our denominator. Okay, so I can go ahead, I can reduce top and bottom now. So x minus 2, oh, I got x plus 1 top and bottom there. And x plus 2 top and bottom. Okay, so there wasn't much to this function. This function just ends up being x plus 7 over x plus 3. Let me double check my notes just to make sure. Okay. Okay, and then notation wise, so this is f divided by g. Ah, that looks ratchet. Horrible. F divided by g, big parentheses of x is equal to. Okay, there you go. That's it. All right, so here are some practice problems. Please pause the video. I would like you to try this one. Pause it right now. Do it. I'm watching you. Okay, so hopefully you pause the video and you tried this. Here is the solution. Simple enough. Watch out for those coefficients. The coefficients will get you. And next practice problem, please pause the video. Okay, and here is the solution to that one. All right, so in this video, we created functions specifically with multiplication and division of two other rational expressions. And we really emphasize, remember, the notation. Okay, so make sure you write that notation of the function. So f divided by g of x. All right, catch you next time. Peace.